Hi, I'm Swarupa Sail, course instructor for Geotechnical Engineering 1. In this presentation, we will go through determination of coefficient of permeability using field test. Field test is more reliable than laboratory test as it involves large mass of soil with minimum disturbance, whereas in laboratory, small soil sample is used. Pumping out test can be carried out for unconfined aquifer and for confined aquifer. Aquifer is a water-bearing stratum in natural ground formations. If aquifer overlies an impervious stratum and water table is free to fluctuate, then it is called unconfined aquifer. And if aquifer is bound by impervious strata both at top and bottom, then it is referred to as confined aquifer. Pumping in test can be constant water level method, that is in open end pipe, so it is referred to as open end test, and packer method wherein it is in section of borehole. It can be single packer test or double packer test. For large engineering projects, permeability is measured by pumping out test. It is useful for homogeneous coarse-grained soil for which it is difficult to obtain undisturbed sample, and this test is very costly. Here in this figure, we can see a main well whose radius is r, and there are various wells which are dug at certain points, and the line which is obtained by joining the water level at various points will give us drawdown curve on both the sides. Let the bottom line be the reference point of the confined aquifer, which is sandwiched between impervious stratum. R is the radius of zero drawdown, which is known as maximum radius of influence, and it is the distance between center of the main well and the point at which the drawdown curve ends. H is the depth of water in main well during pumping, which is measured above impervious layer during pumping, and H is the height of initial water table above impervious layer. That is, it is the height of initial piezometric surface above the impervious stratum. And this impervious piezometric surface is obtained by joining the piezometric head at various points. Piezometric head is nothing but datum head and the pressure head. So, datum head at main well is H, at point 1 is H1 and at point 2 is H2. Similarly, pressure head at main well is S, and at point 1 it is S1 and at point 2 it is S2. And the line which is obtained by joining piezometric head at all the points will give us initial piezometric surface. Let Q be the rate at which water is pumped out of this main well. B is the thickness of confined aquifer. Let Pxy be any point on the drawdown curve. So, Pxy is a point which is selected on the drawdown curve. The origin of reference O is chosen at the bottom of axis of main well. So, the point O is shown here at the bottom of the main well. Let us apply Darcy's law for flow through cylindrical surface of radius x and height b. So Q will be equal to K into AX into IX. K is the coefficient of permeability for which we need to derive the equation. AX will be equal to 2 pi x into B. Ix is dy by dx. So after we rearrange, we get q into dx by x, which is equal to 2 pi b k dy. Let us integrate on both the sides. So q into integration of dx by x, which is equal to 2 pi bk into integration of dy. So after we integrate, we get q log of r by r, which is equal to 2 pi bk h minus h. And the equation for k will be equal to q divided by 2 pi b into h minus h into log of r divided by r. Alternatively, if H1 and H2 are the depths of water measured above bottom impervious stratum in two observation wells which are located at radial distances R1 and R2 from the axis of main well, then we will have Q into integration of dx by x, which is equal to 2 pi bk into integration of dy. After we integrate, we get q log of r2 by r1, which is equal to 2 pi bk h2 minus h1. Now we have equation for k, which is equal to q divided by 2 pi b into h2 minus h1 log of r2 divided by r1. So both these equations can be used to find coefficient of permeability K. Thank you.